Hello. So today we are going to implement the integration of all the things that we implemented, the message decoding part and the serial interface, and we are going to integrate them and make it an entry point to this library. So the IMU class will handle everything, the connection to the sensor, decoding, and also it introduced the subscription thingy that we discussed about. So a third party can easily actually subscribe to the class and start receiving the packets as they come to the system. So let's go do that. Let's start with adding the IMU, of course, the header file and the source code file. And let me clarify this part a little bit. Okay, so let's do that. As we did that multiple times during this the previous episode of this live coding and the previous one. First we need to actually define the if not definition thingy for preventing the repetitive including the header file repetitively. So we did that, and then we defined the macro. So the first time it goes to this block of code, the macro, the PHM WitMotion IMU will be defined, and the next time that this header file included any source file related to the one that you already included, you will it will be ignored. So this block of code won't be won't be included in during the compiling phase. So it's very important to know. So the macro, all of these things that start with not all of them, but this part actually will be read before compile, during compiling. Okay, so the next part is that we need to include the header file that we need. Of course, this list can be partial, so later when during your coding, when you see that you need a header file, you will come here and include those too. So we are going to use the serial one, of course, and the message, because this class will be actually will include all these two header files and integrate all of them together. Perfect. So before we start that, since we want to process the packets and get them and then send it to message to be decoded, all of the messages will start with the flag byte, just for us to know that, okay, this is the starting point based on the documentation of the sensor, of course. And this starting byte is 55 in hexadecimal, and then after that we are actually defining the namespace as we did in the serial, and then we are going to implement the class and the other things that we want. So part of the thing that we need to do is for every packet we need to actually compute the checksum and check if everything is okay. So let's do that. Let's define a class to actually check the checksum and calculate the compute the checksum, and then we go from there. Okay, so just before we go further, let's not Yeah, so I'm going to define it as a lambda, just for because we don't need to do anything else. Let's do that. Oh, yeah, perfect. And for the arguments of this lambda, we have, I'm looking at my notes just to make sure that I don't code something that is not actually accurate, because then we have to come here and change them. And then, okay, so for computing the checksum, we have the code of the message as we discussed in the decoding part. We have the body of that data packet and the length of that data packet. Perfect. And for the logic, so we're gonna implement it here. We don't need to go to the source file to do that, since we are implementing it as a lambda here. So start byte plus, don't worry about okay why I did that, or it's just, if you read the document, it's just very easy. So what I'm doing here is actually I'm extracting the first byte, the low byte, and then because I only need that one. That's the part that the checksum actually that's the part for calculating the checksum that we want that. So let's do this. So we are reading it like one by one, and then we do this. Okay, so we have the body. We just need to add each byte of that body from the lowest byte to the highest byte, like this. Yeah. And then after we calculate that, and the first calculation that we did, we just need to do this, and that's it. Yeah. No. So we convert this to a byte, a signed byte. Okay. Perfect. So the next part that we need to do, so before we go and implement our IMU like class, we need to define our listener, or like an interface for the listener part. So any class that actually implement this interface can be used to can actually subscribe to the IMU class to receive the data packets. That's why I'm defining an abstract class like this, and then I just need to add few abstract classes. Yeah. So let's say receive time packet. Let's say a message, something like that. So why I don't make it like equal to 0? It's just I just make it an empty body. That's fine too for this application. But if you want to make sure that okay, the reason I do this is because if you define all of these as like this, then the class that actually implement this interface need to implement all of these functions. Otherwise it will like raise error during compiling and linking the program. So when you actually make it as an empty body, then what happens is that the class or the subscriber can actually implement only the methods that they want. So they don't need to like make all the unnecessary method empty body. You already did that. Perfect. What else? Receive angular velocity. Yeah. And just to save some time, I'm gonna copy the thing that I already prepared, because we don't need to actually, as you can see, it's just a little bit different than what I implemented before. It was a node, so I didn't care about the code or anything. I just put this here to make sure that I don't forget anything. Okay, we have everything here. Now we go for implementing the IMU class, but let's do something. So let's say you want to make something like a test listener, or something that to be used just to print all the messages that you receive, just to make sure that, okay, maybe that's for your testing or something like that. So let's do that. Let's implement a null subscriber. Yeah. Perfect. So I will implement one, and then I just copy all of them here. So let's say we want to receive the time packet. Of course, we have that, and then we just want to actually print the message. As you remember, we implemented the toString for our messages, and every message had its own toString. Yeah, so that's it. Very easy. I'm gonna copy paste the rest of them here. Perfect. So we have everything here. Just remove these. It's like I'm conditioned to add a semicolon at the end of all of these. I don't know why. Perfect. So we have all of that. Now it's time. Well, we will use this during our test later, but let's go ahead and implement the driver. Private, as we did in our previous episodes, just to add the class field. I prefer to do them first. So we have the baud rate, of course, which determines the sampling rate, and we have, so we are passing these to our serial and message classes later, but let's keep them here also in case we want to use it for later. Yeah, try to make it like I use camel case. Of course, the standard one is the camel case, and IMU listener. Perfect. Great. So let's also define the signature, the function signature for actually the constructor. And also we would need the path to the def file. Yeah, perfect. And also let's because now we got that, let's do a get method for, yeah, perfect. Yeah, and we don't need to implement it in the source file, we just want to return it. And since the return of this is very important and should not be ignored, because this is the only thing that this function does, so let's add the flag no discard. Great. So beside that, we would need to add a function to set the, so for this method, for this class later, if anyone wants to contribute to this repo, or if we want to continue developing and adding more features, we are going to support the multiple subscription to this class. But for now, let's say we have only one listener, so we are doing perfect. And it would be very simple one. Yeah. Okay, so the next step is to add some function that shows the status of the class, and also we need the class to, let's say, open the channel, open everything, or it's beginning, it's the first step to initializing the class for later receiving something. And as we discussed for this episodes, we just implement the receive function. Of course, later we can implement the other part, adding the calibration and sending commands and all of that. Okay, so we can we would need some like internal functions later. We're gonna implement them here, but for now let's go to the source file and start implementing the logic behind all of those methods that we actually included in our class. Of course, we need to include the header, and what we need, we already added the IO stream, so we don't need to include that. And as I mentioned before, since we are using some low level APIs, we may need some C string functions to use actually during our processing of the data and all of that. So let's move this here, and let's expand our our editor window. And now, after we did that, we are going to implement, first let's implement the constructor. So the constructor was baud rate, let's say, and also the, let's say, fdev, and say empty body, and to do so we easily use this. All of you are familiar with how to initialize the things here, so no need to explain here. It's easy. And then let's implement the next function. What is the function? So it should be, yeah, so it will be open. Yeah, it's better to do open. Yeah. So for doing open, let's implement our first internal so init serial, because we want to initialize the serial port, and then also the init serial, of course, for when we want to close it. And yeah, let's do a read packet. Yeah, I'm going off a script now a little bit, just to sometimes it's nice just you think that you have an idea, you pursue it, and when we receive a packet, if you remember, we had a structure that the name was receive packet, and we use that to actually contain or keep the information about the received packet. So we have all of these, and then let's implement the initialization of the serial port first, and then we go from there. Perfect. Yeah, it would be much better. Yeah. And for this one, we are going to initialize the service. So as you remember, you don't need to remember, it's here. We want to implement that, and if you remember, you need to remember a lot of things. We actually implement a function inside a static function inside our serial class for actually initializing and building the serial class that communicates to the serial port, and then we just easily use the begin thingy to start everything. And enough said for yeah. Yeah, so we check if the dev handler actually is not null. That means we already initialized it, and then if it's actually open, because sometimes you initialize it, you close it, but it's already have valid pointer, so it's not null. That's why we have to do this, and then we simply delete the dev handler as we did here. Okay, so we used the is open, but we didn't implement it, so let's do that. Don't need to mention this here. Perfect. So for this one, we just use a simple, of course it can be more complex and more involved, but let's for now do this. Okay, so as all of you know, if this statement is false, it doesn't actually run this one, so we are safe here in case we didn't initialize the thingy yet. Okay, now that we have all the methods that we want, let's implement the open. So for open, we just simply, because for the message class, we don't need any initialization step. So we just need to write what we want. And for the closed one, easy peasy. Okay, now let's do the read packet, which is very important. Okay, for read packet, we have the data packet, which we actually received from our serial port. It was a pointer. Perfect. So we say while, let's say we do this, so it's like a blocking function. So when it goes here, it continue to read packets until we actually close the channel and close the connection. So we say is while is open is valid, which means our connection is valid, our connection is working. We don't worry about implementing a variable here, because the compiler optimize your code and handle this part. So the dev handler, as you remember, it was receive is one of the functions inside the serial class, and we say divide and 1. Yeah. So we read 1 byte, and if it's equal to 0, we continue. Based on the documentation, we are going according to the documentation. And if this one is not start byte, we continue. So sometimes you are connecting or you start reading from the beginning of the class, from in middle of a packet, receiving a packet or something like that. So it's better. So the start byte makes sure that okay, you know from where you are reading. So it's all for you to ensure that you are reading correctly. So let's say yeah. Now we are going to read the header. So we do dev handler receive divide. So we read 1 byte, and again, if it's 0, we just continue. In case the start byte is detected, but the next one is not the header, which means that okay, it's not correctly, the packet is not correct or whatever. So the next part is the receiving the packet body and the rest of things. So for doing that, let's implement the packet. Yeah, and if you remember, we had a body size. Okay, and so what I'm going to do here, I'm going to set all the bytes inside this, like, the memory block 0. Yeah. So since we're working with byte, we don't need to do that. Yeah. Perfect. Now I'm going to receive it. So we, of course, the number of received bytes, we gonna use that later just to make sure we are reading correctly. And then yeah, not this one. And the packet body size +1. Yeah, one of the disadvantages of increasing the font size is that we wouldn't have enough space to see the code, to see a line of code. Okay, so I'm reinterpreting the pack, which was which was an array of int 8, so assigned bytes. So I'm reinterpreting that to an unsigned byte array, and then I start receiving it. That's it. It's not something, those who work with std library, they are familiar with these things. Yeah. Perfect. Okay, so we are making sure that, okay, we received actually the amount of data that we asked for, just to make sure everything is okay. And later I'm going to calculate the compute thingy here. So the last one, the last byte, that's why we make +1. So based on the documentation, the last byte is the CRC, which we calculate, and it should be equal to this one. That's why we are doing that. Yeah, so let's extract the last byte. Now we also need to calculate our own CRC. Yeah, so the code actually is the byte, the one that the header that we the one that we collected, the received by this one, the header one, and then from now on we just working with the packet size that we defined before. Perfect. Yeah. So so if our calculation of CRC is not equal to the one that we receive from the sensor, we need to actually it's a failed like data packet, and we need to skip it. But before we do that, we say, okay, invalid checksum, very easy, and then Yeah, but let's do something here. So we do that invalid checksum, and then let's say, okay, the code, what was the code? And let's say, yeah, instead of just end the line, let's do something. So I want to display the number that actually I'm passing to this. That's why I do std hex. Yeah, divide. So it actually prints the value of divide as a 2-byte integer, but it's displayed as a hex. Yeah, I think that would be enough. We can add more information later, but for now it would be enough. Perfect. So now let's fill the packet, the receive packet. So the packet here, yeah, the packet will be code as I did before for thingy there. I'm just I need to do the dp code, so it converted to the enum that I want. And I'm going to copy the body from the packet that I received. How many bytes? This amount of byte that we mentioned. And for the CRC, we just add that. We don't use it, the CRC, after this, but it would be better to put it there. Maybe we want to save it or something. So this one block the execution. It read until we get the packet completed. We actually complete this packet, and then it goes out of the loop, and we can go and receive the next message. So the main loop that actually read all the packets, every time it goes to this line actually wait until it receives a valid packet, then goes back to the main loop, and again we go for another packet, something like that. Yeah, perfect. Now let's implement one step above this. So we had a function here, receive. Receive. So when we call receive, we actually want to use that read packet. So I define an instance of data packet. I read a packet from the serial. How to do that? I just call read packet and pass this. Sorry, it's pointer, so I need to pass the address of that variable, and then I define a message. Let's nullify it at the beginning, and then if you remember, we had a function for building a message based on the thing that we receive from serial port. And this one actually give us what we want, but again, as you may remember, it will not initialize that variable in case of any error, so we do that, and then we say, okay, now that you get it, parse it. Okay, so now we have another method that we didn't implement it yet, but it's a dispatch here. So we do dispatch the message. That's it. And then for memory management, we delete the message. So again, to make sure that we don't get any error, remember that this one needs to be a blocking function. You cannot make a thread and start working, because the moment it come out of this function, the pointer will be deleted, and the memory associated to this pointer will be deleted. Perfect. And now let's implement the IMU driver thingy for dispatch. Okay, receive packet. So basically what I'm going to do, because we don't receive all of the data types at once, so maybe the first packet is time, the second is acceleration, the third is, I don't know, GPS, is mixed up. So we need to call the correct function, correct listener every time we receive packets. So it's just a simple switch thingy. Yeah, based on the code that we received. And let's say if it's time, yeah, if it's time, I say listener on receive time. Yeah, and for passing it, we need to convert our message to the received message to the time packet. So that's why I do something like that, just to make sure that we don't waste our time. I'm going to copy the rest here. We don't need to implement everything. And for this one, yeah. Yeah, correct. Perfect. And for the default one, we just need to warn that, okay, the packet is not, the code is not supported, or we didn't handle it, or something like that. Yeah. Okay, that would be it. For now, yeah, that would be it. Now let's go and implement a main function. Let's do something. Let's create a test So I create a test folder, and then I do test serial. Yeah, it's just to make sure we do also one unit test here. It won't be a unit test, but let's do something similar. So for this one, of course we want to print something, so let's do that. And then we, of course, we need unicity, and then also a string. And we would need the IMU thingy. So let's implement the main function, and at the end we are going to implement this CMake file for being able to compile everything together. Yeah, something like that. And let's do the file. So for the Ubuntu, it will be TTY. Of course you need to check it, but since I already checked it, it will be this one. Yeah, and for this sensor we are going to use 230 400 for our sampling rate, and we are passing the file that we want to use to connect to the sensor. And also I need to introduce the subscriber, the listener. So let's use the one that we already implemented. What was the name? Yeah, this one. So and to do that, we introduce, okay, what is our listener to our IMU driver, and then we okay, there is a problem in our definition. Good thing that we see that before. Okay. Of course. And then we open it. I just let the system wait for 1 second before we go starting the reading process. And then since it's a test, I just want to receive like 200 packets. Yeah. Of course. Something like that. Okay, now that we have our test file, Let's also implement our CMake file. Yeah. Okay, so we need to introduce what is our minimum CMake version required. Let's go with 2.10, and then let's name our project. And what languages we are going to use. Of course, here we do C and C++. Yeah. And as always, I'm going to copy paste this part. Perfect. And yeah, so we are going to check if the environment is Linux, because this method, this library, it only works if we are using Linux. Sorry. Great. Let's end the if before. It's better you define your block before start writing the logic inside your block, because sometimes you forget about, okay, did I forget to end it, and then you receive error messages, and then you need to go through your code and all of that. I'm gonna erase an error, fatal error one, like this libraries only supports Linux. Yeah. Perfect. And now let's also, you can do this or not, but of course we are not supporting logs here, but let's practice here, and later when you want to use logs, you have the infrastructure for it. So I'm going to make a directory, and oh, brought it, but I don't want. Okay, so I'm going to do CMake current source dir. Perfect. And then logs. So we make sure that even if we are building inside the build folder, we are creating or making our directory inside the root directory of our project. Now let's build the environment. We went through this in our previous program, so we don't need to do anything about it. It's easy. And now, so what I want to do is that I make a library of the code that I implemented, and then I use that library for an execution file. I don't include all of this for execution file. It's just I make a library and an execution file. It actually helps you to use this for, okay, I want to use this library for multiple execution files, something like that. So you define a library and then you add it to different execution for your execution file. So let's define a variable. Yeah. Okay, I want to name my library Just something like that. Yeah, PHM WitMotion IMU driver. Yeah, and now I want to include all the header files and all the yeah. I thought for the second it understood what I want to do, but I'm naive. Yeah. So all the files with file extension H inside the include folder, and also for sources I want to add all the files with file extension CPP. I want to include them. So this one, create a set a variable and add all of these path of all of these files inside that variable, and also this one. So later we are going to use it. For example, here, well, not here, but later. Before we include all of this, let's also define our include directory here. Perfect. Now I want to create my library, so I say add library. So the name that I define already is the shared library, and thing that I put here. Great. And also include victories. Yeah, it's not something that I want to write. And also there are some flags that we need for, like the sign character and if it's like protector. These are straightforward for this. And also we need to also define this just to make sure we don't waste time implementing all of that. Just so if it's a GNU, and if the version of the compiler is less than 8, we actually need to use this one, and if it's more than 9 we need to include this one. So it's like make sure that we have the file system, STD file system that we want. Yeah. Also, we use boost, so we need to find the package boost, and we make it required. Why we do required? Because then if it cannot find it, the CMake process will be actually stopped. And also I'm telling that, okay, use the static libraries instead of the shared one, so it will be included inside the source. And from boost I need to also add the log in case I want to use it, and also So do you remember the include directories? We need to include the, well, I didn't put that here, but I already added the logs. So if you go to the repo, you will see it. That's why I'm adding it here. I just bring it from here. I don't need to. Yeah, being lazy have some downsides also. So now I want to install. So I want to copy the resulted one, the resulted files, where to so the libraries. I mean, I need to bring all of these libraries that I created to the build folder. Yeah. Destination is the build folder, the one that we already are doing. So here is done. If you compile this, your library is there. But we want to actually compile that testing one too. So what we need to do, first we need to enable the testing. And then we want to add the test. What is the test? Yeah. Sorry. So for the name, let's say serial, and then command will be test serial. Yeah. Test serial. Perfect. And then we do, okay, I don't need to write all of this again. Just copy paste it. And then also I'm linking the library that we compiled to this test that I created. And that would be it. Very easy. So next part, we are going to show you how we compile it and we run it to see how it works.